So the need of process control, all this blah blah blah, you can read by yourself. Okay. Okay, moving on to the important part of process control. Okay. I don't blame you if you don't really understand process control last time when you learn it with me or with other lecturer. It's okay. For the first time, you learn something that really new, and the mythos from my previous one, even from my lecturer, process control is the most curious subject, okay, among the others, because it's very difficult to understand. It's a lot of term that you have to understand, but it's okay. Today I'm going to explain again to you what is control variable, what is manipulated variable. Hopefully you can have that simple, you can get the concept. Okay, the first one is a control variable. Control variable, what does it mean by variable? Variables mean it's something that keep on changing, something that fixed. We call it as a constant. Okay, we never control constant. We control, we manipulate, we control something that varies by time. That's why it's called variable, because it keep on changing by time. Control means we control it. We want it to be at specific value. That specific value is named as set point. For example, we want a temperature to be 300 degrees C. So the temperature is our control variable. Okay, the temperature, it keep on changing unless you control it. You want it to be 300 or plus minus 5 degrees C. Okay, that is the meaning by in a specific range. Okay, you don't want that temperature to be 400. No, you want it to be at 300. Why? Because maybe your reaction take place at 300 degrees C. And because of that, you just need 300 degrees C of temperature. You don't need 400. It is you oversupply the heat. Okay, you lose some money there, or you don't undersupply, which is the temperature is not yet 300. You want it to be, for example, you want it to be at 300 degrees C. Okay, that 300 degrees C is a set point. The temperature itself is the control variable. Okay, hope you can understand what is control variable. Okay, the variable that you want to control. Okay, the variable that you want it to be at specific value. You want a temperature. So temperature is your control variable. Same goes if you want a pressure to be at 10 bar. So your control variable is pressure. Okay. So choosing a control variable for your equipment, you have to understand what is the function of your equipment. For example, your reactor. Your reactor for the reaction to take place. Okay. So at what temperature your reaction should take place? It's not the same between the group. Okay, it's up to your reaction at what temperature. Okay, and you have to aware that your reaction is endothermic or exothermic. Is endothermic, you have to supply the heat. Whereas for exothermic, you have to put a cooling system to reduce the temperature. Okay. For the manipulated variable is the variable that we manipulate, we change so that it will change the control variable. For example, the temperature. Okay, we manipulate the amount of steam, the steam flow rate, for example, in order to increase the temperature. Okay. What about to reduce the temperature? To reduce the temperature, we manipulate the coolant flow rate. Okay. To increase the temperature, we manipulate the steam flow rate or the steam pressure. Okay. What about disturbance variable? Disturbance variable is the variable that disturbs your system. But you have to identify that disturbance really disturbs your control variable or not. For example, let's say, again, your control variable is your temperature. So what disturbs the temperature? It could be a flow rate. It could be a reaction itself. Let's say it is exothermic reaction. Okay, of course you have to, of course, the disturbance variable is something that affect your control variable. Okay, but you don't say composition. Let's say a composition is your disturbance. Correct or not? You should have a clear relationship between disturbance variable to manipulated variable, disturbance variable to control variable, manipulated variable to control variable. Okay? Don't say composition is your disturbance variable unless you can tell me as the composition increase, what happened to your temperature? Is that your temperature increase? Okay, same goes with manipulated variable. Something that really connected to each other. For example, as the flow rate increase, the temperature increase. Flow rate decrease, temperature decrease. Same goes with your disturbance. Is your feed flow rate increase? What happened to your level? Increase or decrease? Okay, you don't say something that not related. Please don't just do it. Okay, I have experience laughing at your report. Okay, so set point, as I said previously, set point is the specific value of that control variable. You want it to be 300, so 300 is your set point. You want it to be 10 bar, so 10 bar is your set point. Okay. The fifth one is a sensor, of course. You have to measure. You cannot control something that you cannot measure. You have to measure it, so you know it, how much you want it to be. Okay, you measure it so that you know what is the current value. If you want a temperature to be your control variable, you have to measure the temperature. If you want a flow rate to be your manipulated variable, you have to measure the flow rate so that you can manipulate it, whether to decrease or to increase it. Because if you don't measure, how do you know to decrease how much? Okay, to increase how much? Everything should goes by number. Okay. The sixth one is the final control element. For the final control element, basically most of the cases is the control valve itself, whereby you are controlling the flow rate. But there are also some cases that heater might be a heater or might be another element that according to your process. For example, in a bioreactor, in a fermenter, you have something like oxygen dissolve, okay, the form and everything. So just choose your final control element correctly. Not everything necessary. Not everything have to be a control valve. It can be something else. Okay, you can refer more to your supervisor. Okay, and the most important thing is you need a controller. Without a controller, you cannot control a process automatically. You have to do it manually. You have to go there, sit beside the valve, open when it needed or close when it doesn't need the flow rate. Okay, that's why we need a controller. So the controller will do the job for you, as it will compare the current value and set point value, whether it is the same or which one is higher, which one is lower, and it will give instruction to your final control element whether to open, to close, to reduce, to increase. Okay. Okay, for the control terminology, continue. This is the definition. Okay, the definition for control variables, set point, final control element, and a controller is okay. It's just the definition. Okay, this is, like I said, you can just read it. The most important thing is you should understand it. Okay,